Hello everyone, and I'm Łukasz, and I wanted to talk about clean architecture in general. Although I realized I might have misled you with the title, with the practical part, because it's not going to be code samples or some specific way of how I write clean architecture, but this is going to be kind of the knowledge that I wish I would have heard from someone when I was starting being interested in clean architecture in general, because I found myself looking at lots of code samples that I kind of understood what they do, but I didn't understand why, and I wanted to give you like the why of clean architecture. By the way, how many of you are Android developers and iOS? Okay. And how many of you know clean architecture? Like say they're comfortable with clean architecture. Okay, cool. And how many of you write code that they think is clean? Like you don't have really a problem with writing clean. Okay. Okay, that's a high bar actually. So is there anyone who doesn't like clean architecture? Can I skip this slide? I will not. So anyway, basically, writing code that works. We know that the code works because we can just run the app and it works, right? That's easy. But writing code that is right is actually more difficult because we don't know that the code isn't right until we are bitten by it. So clean architecture is like the tried already way to write clean code, which is almost guaranteed to be maintainable and nice to work with in the future. It does pay off in the long run. If you're writing MVP, like 3 weeks or 4 weeks worth of project, you don't want to bother with clean architecture. But if you're writing something that will be maintained for a couple of months, then it will pay off. Even though you probably think that it's a big investment, it will pay off definitely. And then it's fun, because they're Android developers. So of you, who likes Android framework? Callbacks, lifecycle, all the fun stuff. It sucks. I mean, yeah. I'm an Android developer, so I know. And clean architecture lets us write the application and postpone all the Android stuff till the end. So it's actually, you can write code without bothering with Android until the very end, which is nice. So what is architecture? It's kind of difficult to talk about specific architecture if you don't know what the architecture is about. I found three very popular definitions, four actually. This is the one from IEEE standard, and you don't have to read it because it sucks. It's not really useful. It's like tons of documents about what is an architecture, who is an architect, what is the output of architects' work, not useful at all for anyone except maybe corporations. Then we have a definition which says it's the shared understanding of the system, which is already kind of interesting definition, because it means that even if you think there is no architecture in a project, that there always is some architecture in the project. And if you ask senior developers who build something, how they understand the system, they will tell you, and this is the architecture. And it's like, there's always some architecture. And then, my favorite definition is that these are the decisions which are important and hard to change, which is also, raises some important questions like, is the choice of language an architecture? Because it's an important decision and it's hard to make. And these two the two bottom definitions were merged into one by Ralph Johnson, which basically says this is the important stuff, which is kind of makes sense, right? And surprisingly, this definition is very useful in the context of clean architecture, because clean architecture doesn't tell you exactly how to write your application. It doesn't tell you have this class, and this must be the interface, and this. It's not a recipe. It's just the set of things that are important according to the author of clean architecture. So if we keep in mind what is important in the context of clean architecture and we abide by those rules, then any app that we write is clean. It doesn't have to be some very specific code. So what is important? for the author of the clean architecture, and that's obviously my interpretation, but based on the blog post, The Clean Architecture from the 2012. And first of all, this is separation of business. We'll talk in a bit about what exactly the business is, but there is a business and it must be separate from everything else. Then basically everything must be separate from the frameworks, which is kind of also separation of concerns, but it's stressed even more than that the frameworks are completely separate from the application. It must be testable, obviously. It must be easy to delay decisions. Like if you have to make a decision, clean architecture tells you you must be able to make this decision as late as possible and gather as much information as you can. And finally, you need to abide by what's called the dependency rule, which is the easiest to. I didn't want to include this diagram, but this is talk about clean architecture, so I kind of had to. It wouldn't be a serious talk about clean architecture without it. But anyway, there are four layers, and the dependency rule says that you can only talk. The outer layer can only know about the inner layers, and you can't know from the other way around. So in this case, controllers and gateways and presenters will know about the use cases, but it's forbidden. It is forbidden for use cases to know anything about the controllers. It is forbidden for presenters to know anything about the UI, and for entities to know anything about anything, really. And this is the dependency rule, the most important, basically, rule of clean architecture. So I'll go over those layers one by one, and just not only throwing out definitions, what is what, but also talking some more about what actually goes in there so that it's more clear. But first, we're talking about the business logic, and the domain, and whatever. So just a quick word about what is exactly business in the domain. And business is not really well defined. It's whatever you work with to build a software. And someone needs a software, something, some company, whatever, that's a business. The important thing is that business always operates within some domain. And this domain is, kind of part of the world on which the business operates on. For example, Mobile Warsaw is a business, even though it probably doesn't earn money, I think. It is a business, though, and it operates within a domain of organizing Mobile Warsaw meetup. And when we speak about the domain, we need to more or less have an idea what it is. What is important, though, is that the domain is unique. If I go to Wrocław, and there is Toast Wrocław, which is a Wrocław meetup about mobile application development. If any of the organizers of Mobile Warsaw go to Wrocław, they can't say, yeah, I know how to organize your meetup, because it's also a meetup. Even though there will be probably very similar concepts, like the venue and the meetup and the speakers and presentations, etc., it is inherently different because it's a different business. So every domain is unique for the business in which it's defined. So the first layer, the most inner layer of this entire architecture, and it can't know anything about anything else, is the enterprise business rules. And this is mostly entities, which is a catch-all words for basically everything that you need to explain the domain. There will be an example in a bit. What's important is that it is domain-specific, not application-specific, which means if you write this domain once, it is not specific to an application. It's not like I'm writing this application, so I need this domain. The domain is true for the business and for for whatever the company does. And it's not really connected to any application. It's just some set of things that are true about a business. So we can take this one domain and reuse it across applications. We can write a domain once, and if the Mobile Warsaw were to write an application for the guests, for you, to know when is the next meetup and whatever, and we would define this domain, and they would then decide that they want an application for the speakers, they could reuse this domain because the speaker for the guests is the same thing as the speaker for speakers. It doesn't really change often. If anything, it changes because you're adding things to it and building it, and not because something changes, because it's really talks about some reality, and it shouldn't change. And the most important thing is that it's defined by the domain expert, which is someone who knows everything about how the business works. If I wanted to talk about Mobile Warsaw, I would approach one of the organizers and ask them about things about Mobile Warsaw. So let's take, for example, Mobile Warsaw domain. So the entities, I said it's catch-all. It's anything that we need to kind of model the domain, right? So I could say that there's probably a meetup which has some presentations. Can you see it? Yeah. There must be a meetup, right? And it has presentations, and it has venue, and then the presentation has a speaker title, length, etc., right? So this is the domain. Who would say it's reasonable? Who would say it's not? Does it make sense, more or less, that this would be the domain? It explains kind of part of reality about the Mobile Warsaw, that we need those models and things, right? Only it's not really correct, because I wrote it at home when preparing for this presentation, and I didn't really talk to anyone, and especially not to the domain experts of Mobile Warsaw, which are the organizers. So I didn't really know that the speaker will have a name or that the meetup will have a list of presentations, because I could guess probably. It does make sense to guess some things, but I couldn't really know. So instead, when you're building the domain, you would want to sit with the domain expert, or at least have easy access to them, and you'll start a conversation. What kind of objects we have or entities in the context of Mobile Warsaw? So most importantly, they will say it's a meetup. Okay, so what's important about the meetup? It's probably some presentations on this meetup, right? So I can start writing code based on what I hear from the domain expert. But they will say, there are meetups, so I will say a list. But then I'm inquisitive, and I will ask, so can I have 2 of the same presentations on one meetup? And they will say, well, no, because that wouldn't make much sense. So it doesn't make sense to have meetups modeled as a list. It's probably a set, because I can have 2 of the same on one meetup. But then I ask further. Does it matter which presentation is first? And it turns out it does. So I need to order this set of presentations. So I need to use some ordered set. And then we're talking, and it turns out that it doesn't really make sense to have 10 presentations on one meetup. There's never 10 presentations or even 5. And it turns out that the domain expert will tell me that on Mobile Warsaw, there's either 2 or 3 presentations always. If there's 1, then they don't organize it. If there's 4, then they move someone to the next one. So in the end, we end up with something that really resembles the reality of the domain of Mobile Warsaw. And obviously, meetup will have a lot more properties and a lot more things that are important about it. And then we will just talk about it with the domain expert and figure it out. And this model, this meetup, we don't talk about any application yet, right? There is no application for guests or for speakers. We know that this just is part of of what Mobile Warsaw organizers work with. So the important thing is that we need to find someone who knows about the domain and talk to them, basically. It's also discovered, not invented. It's not like we will ask them what is a meetup and they will start thinking, new stuff about a meetup. They will try and explain what they know and not think about new stuff. And basically, with the domain, the only thing that we as programmers must do is translate it into the code, because ideally, it would be the domain expert who just sits and writes code, because they know the domain, and it should be relatively easy to write it. But typically, they don't write code. So yeah. And obviously, we don't have to build the entire domain before we start working on a project. It doesn't make much sense. But we need to keep in mind that it is entirely separate from everything else. So every time we think about the domain, we can't really think about the application or the API or the database or anything of the implementation. This is just talking about the reality. And also what's kind of important is that you really need to try to be as close to the reality as possible, but also stick with the language that you have. So If you have sealed classes in Kotlin, you will use those. If you have enums with associated types in Swift, you will use those. In Java, you can't really use sealed classes. It's not practical. So you will use whatever Java gives you. And then you can't really take new things, like new libraries and stuff to the domain, because the point of the domain is that it is independent of absolutely everything except the necessary, and the necessary is just the language that you're using. Except in reality, I allow things I call language extensions. And these are things that I can reasonably argue should be part of the language. So for Kotlin, it's obviously Kotlin standard library, which calls all the functions that are useful. But also, for example, the 310BP, it's a library to handle time in Java. And normal Java API for time just is terrible, and this is great. So I allow that because it is really practical choice to include it. But you wouldn't want anything, not much more. And then, so we have entities, and this will probably be just some structures that describe objects in the domain. And then you will have business rules, which are things that are true about the domain in terms of like functionality, some rules, some what is, things that basically some functions about that answer questions about the domain. Again, irrespective of the application. So that was the domain. That was the most inner layer. Then we have the next layer, which already talks about application. So we kind of explained to ourselves the entire domain. We know more or less what's going on. We know that we will have entities like the speaker, the presentation, meetup, event, venue, etc. And now we can start talking about what kind of application we want to actually build, because we all, this leads to building an application. And application business rules, this second layer, is already, we define it once per application, but it's also once per application and not once per platform. So this layer, this application business rules, we will talk about it once, and it is true for Android application, iOS application, Windows Phone, probably web if we want to. And this is where we define all the value for the user, because we build applications purely for the users, and this captures the essence of what's valuable for the user in the application. That I said, you can use it across platforms. And when I say that you can use stuff across platforms, or that something is not limited to one platform, it's not that I'm proposing to, for example, write code in C++ and reuse it across Android and iOS, or to write Kotlin and cross-compile it to native. What I mean is that you can probably quite reasonably write code in Kotlin and in Swift, and it will look exactly the same. It will have the same names, it will have the same dependencies, the same types, or at least their respective counterparts. So this would probably look exactly the same in Kotlin and in Swift. And this, we talked about the domain entities and that they're defined by the domain expert. This is defined by the product owner, which is a person who knows what we want to give to the users. The primary thing that is defined in this layer are the use cases, and basically each use case is some value for the user, right? So for example, we will talk with the product owner, and they will say that we are building an application for the guests, and the idea for the value is that they will be able to see the list of upcoming meetups, see some details, and apply as a speaker. And that's essentially, they will tell us that they want the application to do that. Now, we as programmers will translate these use cases, which is some kind of idea about the functionality, into some code classes, probably. So what we will do is we can capture those use cases in things called interactors, which is already some specific entity in the code which is responsible for delivering this particular functionality and executing all the logic related to it. For example, let's say we're talking to the product owner, and they will say, we want the user to be able to the user of the application to be able to apply as a speaker. And what will happen is they will submit a proposal. So we can, we're writing code, so we know that we need to accept some kind of proposal type and whatever, and then execute some logic of this. And this logic is defined within the use case by the product owner. They will say that, okay, so now when someone tries to apply, we will first check that this proposal is valid according to some business rules, which will be in this first layer in the domain. That's why it's yellow. Like the colors are the same as in this diagram, right? So we should first check that the proposal is valid. If it's valid, then we can go on. If not, then we should probably short circuit. Then we'll want to save this proposal somewhere. We don't know exactly yet, but we know we'll want to save it. Sorry, this says proposal saver, and it's also red. And then we will want to notify someone, probably the organizers, that there's a new proposal. And this is what the product owner told us. And we captured this in code, so we just, we were calling methods on some interfaces to do things. What's important here is that, and then we want to obviously indicate to the user that whether their application was successful. And this is, like, we have this in the code. It doesn't matter yet exactly how this use case this interactor will look like. There are lots of patterns that we can use, but the idea is that it's defined there, and all the dependencies for the use case are also defined right with it, right? So we just define the use case, and we write the code, and we define usually interfaces protocols, which we know we will need. We will need something to save the proposal and something to notify the organizers. And so this diagram, right, it didn't say anything about Android or iOS or anything about any specific library that we'll use to save stuff. So it will work exactly the same on both platforms. And by that, I mean it will have exactly the same interfaces, protocols, exactly the same methods in those protocols. It will call exactly the same logic in the same order, and it will have to pass the same tests. So again, if we're writing Kotlin and Swift, then it is entirely possible to write, for example, Android guy will write Kotlin Interactor, and the iOS, someone from iOS will write tests for it, and then they will swap the code bases, and one will translate Swift to Kotlin and Kotlin to Swift, and everything should work. Because it's still, again, no framework, no dependencies, nothing specific to either platform. And that's important. That this is possible because we're still writing without any dependencies and define all the dependencies as interfaces, which we will then inject. And also, kind of important thing that's not really mentioned often is that the interactor will have no state. State is also a dependency of the interactor, because it doesn't really make much sense if you have one interactor and call it twice, and you have two interactors and call it one and then the other. If they're the same, there should be no difference between those two situations. If your interactor holds state, it starts to be a problem. So state is always a dependency of the interactor, even if it's in a memory, some kind of map or something. Again, so that's one thing. Then what's important is that interactor will perform some series of actions, and it's like a definition of interactor, right? That they will perform series of actions, which means that if you find yourself in a situation where you call 2 or 3 interactors, one after the other, that probably means that this is actually one use case and one interactor. Because the interactor, by definition, is a series of steps. So if you need to always take the same steps one after another, that means it's just one interactor. So just watch out for that, because it's kind of sometimes tricky, because you find it's easy to kind of cut yourself writing interactors for some simple things like, should this button be visible? Because you can say, yeah, this is some feature for the user that the button is visible. But if you find yourself building a view and calling 10 interactors to find out 10 different things, that's probably not the way to go. It is independent from user interface. And from user interface, I mean it should be completely irrelevant how the user interface looks. And a good use case is when you can imagine yourself calling some landline and saying all the things that you should pass to the use case, and then imagine someone doing the logic manually and then giving you the result. Like it should have nothing to do with the UI, with having buttons or tapping buttons. Basically, the user interface is completely irrelevant. And it should be like completely up. You can imagine whatever abstract user interface you can, and it should work with this use case. And and this is kind of why I didn't want to also go into the very specific kind of code samples, because these things, the interactors and whatever, they can have like very various forms. For example, you can get the arguments in the constructor and then have a callback to notify of the result. You can use some Rx Java, Rx Swift to return values, or you can get the parameters in the method and then return a suspended function or whatever you have in Swift. It doesn't really matter. What matters is the code inside and the dependencies that it has, nothing else. So this entire layer, again, the second one, consists of interactors, interfaces defined as the dependencies of those interactors. Whatever we need, we'll just put it as an interface there. And then things that also isn't that obvious, we are allowed other methods, other classes here. We are programming, so if we see some pattern that we want to apply, some command pattern or whatever else, it's perfectly fine to split your interactors into a couple of different classes. But what we need to keep in mind is that those other classes are not public. The only public thing that goes out of this layer are the interactors, nothing else. And obviously the interfaces, but just to implement them. Okay, so we have the business logic, the entities, and then we have the application logic. And then we have the interface adapters. And this is kind of where things start to get kind of hand-wavy, let's say. Because this is defined in clean architecture as the implementations that we need. So we have just defined some interfaces for the dependencies that we need in the use cases. And it is said that this layer will just implement those interfaces somehow. But this is not really that strict. We'll see in a bit why. What I understand as interface adapters is basically the entry point to the domain from the framework. Because if you imagine, actually we'll have this in a bit. The important thing is that this layer is still independent from any library. And so if you imagine some interactor, any, and this is in the business application business logic layer, how we communicate with it? We have to call methods. But then on the other end we have the user, and the user will tap some stuff on the phone or do whatever, and will expect result on his on his screen. And this thing in the middle is exactly the interface adapter. So this is something that allows us to connect some external world with the code that we have written that does the logic that is the core of the application. And so talking about specific example, and I think it's the one of the few examples of actual interface adapters that are found in the wild, is the UI logic. Because UI logic, okay, I kind of missed one thing. By definition, interface adapters will map from the domain stuff to some stuff that is understandable by the frameworks, but by the, say, outside world. So you will need some representation that is kind of still not dependent on the framework, but useful for it. And in terms of having some presentation or UI logic, it's easy to imagine this as basically some kind of some way of notifying the UI logic that the user has pressed a button, for example, and to say that something should be visible on the screen. And we have, for example, live data and data binding on the Android, and this can be defined just as an object with callbacks and methods, right? And then we have, if we get a callback that the user has clicked a button, that's something that goes from the outside. And if we call a method that we want to show something on the screen, it goes that way. But it still doesn't know anything about what specific framework will be used. Is it iOS or Android or data binding or whatever else? So the definition of interface adapter is that there will be this logic that maps to some representation, intermediate representation that is useful for the framework, but not really tied to it. So then we'll have the user, and the user will communicate with it, and the framework, what it will do, it will translate the framework layer, will translate from whatever user does to this intermediate representation, which is understandable now by the logic, which in turn will call the domain layer and translate whatever comes from the domain layer and give it to the framework. And this is difficult, but the idea is that interface adapters are the way of connecting the framework with the domain. But then we have the frameworks and drivers, and actually it's more useful to think of it as framework and libraries, in our case at least. And this is already all the details, and this is what the clean architecture wants us to defer the decisions about. We don't really want to write this in the beginning when we don't want to write the database when we just start. We want to have the application more or less fleshed out, and only then we need to decide whether we want to use data binding or Jetpack Compose. And the idea is that this will change because this will have bugs or we will change some technical decisions. So it must be easily swappable. We should be able to swap some part of this, plug in another one, and nothing about the application should change. None of the inner layers should change. And that's why we needed this joystick in the middle, right? Because if you wanted to change the framework layer into something else, then UI will still use the same representation of what was happening on the UI. And here in this layer, we do really want to write the minimal amount of code that is required for the app to compile and work. Like the less, the better. And then it's plural. We have frameworks and libraries, and the fact that they are in the same layer doesn't mean that they are allowed to talk to each other. If we have some networking library and database and the UI, it is not okay for the UI to directly call networking or database, even though it's the same layer. So that's just not how it works. And now where it gets kind of tricky, let's go back to the application business logic, right? We have the ApplyAsSpeaker Interactor. And we already know that there is some proposal saver, something that will save us the proposal. And we don't know yet exactly where it will be added to the database or to the network cloud immediately, or maybe just to the disk as a file or whatever. And what typically happens is that we will implement this interface, proposal saver, directly in the frameworks and drivers layer. So we will skip the interface adapters because it's not really useful most of the time. It is useful if we have this kind of complex logic, like the UI logic, and this intermediate representation is useful. But most of the time, it's not. Like we can take this interface from the business logic, implement it directly, and it's fine. And this will do whatever it needs to do, which is map to some representation useful for the library, make a network call, map the answer, and notify the user. And this is the minimal amount of code that's needed to work here, right? And that's because basically the libraries that we use often do both of the things at once. They will map, and then they will also do this actual framework thing. We don't have to write the interface adapter. And how to know whether we need this layer of interface adapters or not. Basically, if you implement an interface from the business logic layer, and you want to swap it to something else. I have written a REST API, and I want to swap it to GraphQL API. The question that I need to ask myself is, if I swapped retrofit for GraphQL, would I have to copy some code from the retrofit stuff to the GraphQL? Or would any code be similar? If yes, that means this code belongs either to interface adapters or to the domain. If not, that's fine, because that's exactly what we were trying to achieve, which is we can swap the implementation without anything changing. So I just said that. So this is how it looks like on the diagram. But I wanted to kind of fix this diagram a little bit because I find it really helps in actually thinking about clean architecture. First, as I mentioned, frameworks, drivers, everything are separate from each other. So it is separate from each other. UI doesn't, and we know that the dependencies go inwards. So UI can know about interface adapters and use cases and entities. There is nothing about, there were no arrows within the same layer. So database cannot know about the UI. Well, since we already split this, it does make sense also to split the interface adapters. And just be aware of the fact that if we have interface adapters specific for the presentation and specific for something else, they really shouldn't talk to each other. And the most common violation of this is that networking will immediately cache stuff in the database, for example. They're just not allowed. And then we know that we often don't need those green parts, the interface adapters. So the end result looks like this. And now it's clear that, for example, anything that happens with the application, most of the things that happens with the application in real life will go from the UI through presenters and to the use cases. Now, the use cases the interactors are the only public things. So whenever something happens, is triggered on the UI, it will go through presenters and to the use cases. And then if we see that all other dependencies are forbidden than the inwards ones, it's kind of clear that the interactors must have most of the logic of the application, because they're the only entities in the entire system that know about, that can communicate, for example, with the database, because they have the interface defined. So the use cases are kind of the central thing that will know about most of the things and can orchestrate the entire logic. And one thing that is very important for me personally is that this green thing, which says presenters, this is where your presentation lives, which is the entire MVP, MVVM, MVI, whatever, MV, whatever is popular at the moment. This is there. So like if someone asks you what kind of architecture do you use and you say MVP, that's a no-no, because MVP is just like 10%, 15% of the application. It's definitely not the architecture. And the other thing that's kind of not really well defined, nothing here has dependency on everything, because that's the clean architecture. But we still need some entry point to the application, and that's typically some application module in Android and some DI, dependency injection framework, and whatever. And this is kind of exception where you really need something that has access to everything, but the only responsibility of that is to plug in all the components and let everything know what to inject so that the application works. And like this modularization. I think without introducing modules and modules defined as separate units of compilation, it's really very difficult to have a successful clean architecture application. Because if you don't, with the modules, you can define the dependencies. So if you have a separate module for the UI, then you always need to define some dependencies for this module. And you will say that the only dependencies for the UI are the use cases, and you don't even have physical access to the database or anything else. And if you don't enforce it by the build system, then you will cross the dependencies in the wrong way. You will reach out when you shouldn't, and that's not because that's because it's impossible for a person, for a human, to actually not make that mistake in a big system. Basically, you need to forbid it. So with Gradle, we will use subprojects, And really, I encourage everyone to look into Gradle a bit more. I feel like it's really underappreciated in the Android community because everything is already generated when we start a project, and then we just need to copy some stuff and it works. But it's really, there's more and more materials on Gradle and how to actually set up a multi-project system with Gradle in an easy way. It's really not difficult to maintain. It's just a couple of classes and you're fine. With Swift, I know you have something like frameworks, I guess. I hear it's difficult to use frameworks and actually have like 10 or 20 separate compilation units in Swift. But I also hear that if you don't know that, then it's possible. So, if you don't know that, it's difficult. And then you can consider things like Bazel, which is amazing because Bazel actually defines dependencies per class or per package. So it like brings the modularization to the entirely new level. So what you want to do is you want to set up those dependencies, and every separate component that we had on this diagram before, it should be its own separate module. And then for these modules, you can set proper dependencies, which means that the domain will have no external dependencies whatsoever, nothing at all, except the language extension that I mentioned. Then the use cases will have no dependencies at all, except for the domain, obviously. And it means it won't have Android dependencies, iOS dependencies. It is kind of useful to introduce things like RxJava or coroutines because it like allows you to do the proper data flow, but it's still, you need to consider it as part of the language. Like in Dart, you have streams in language, in Kotlin you don't, so it kind of makes sense to introduce it here as well. But it's not like an external dependency. It's not a library that you, if you introduce a dependency here, don't plan on changing it anytime soon. Like changing it would be massive amount of effort. Then we have the interface adapters, which again are pretty rare, in fact, and they also don't have any external dependencies. And this is, I think, lots of confusion comes from the fact that we are told to implement the interfaces from the domain in this layer, and then it's usually convenient to implement those interfaces by something that already uses the library, uses REST or database or stuff. So remember that this is rare and still shouldn't have any dependencies on any libraries or any frameworks. Again, except things that are reasonable. If you have a library that manages MVP for you, that's obviously something that you can put there. I personally put Android dependencies for my presentation only to have view model and live data. And that's, but don't consider it part of the framework. And then for every separate implementation in the frameworks module, you will have only the dependency that you actually need, and everything, and everything inwards. Yep. So kind of, I was actually pretty happy that this is a joint Android iOS meetup because clean architecture works really well if both Android and iOS developers on the project want to try clean architecture in it. So you can actually write business rules together. You can sit together and one will write business rules for some part of the domain in Kotlin and Swift, and you can swap the implementation and just translate Kotlin to Swift. You don't have to even think about it. You can write application business logic together. One will write an interactor, the other one will write tests, and then swap, translate, and it should also work. You can consider similar stack, and not in a way that you should limit one platform or another. But if Android application uses RxJava, then it's reasonable for iOS to use RxSwift and just call things exactly the same, and it will be much easier to find yourself around. And enforce proper dependencies. This is just this is the most important thing. Make it impossible to make a mistake by calling some things that you shouldn't. And talk to each other, basically, the Android and iOS, but not in the kitchen, but about the code, really. And the most important thing, MVP is not an architecture. Please don't call MVP an architecture. There are some links. Right. The presentation will be on YouTube. So, so I don't know why those are clickable. There's one very interesting presentation about how to really model the domain using Kotlin, like what's useful in Kotlin to model the domain. There is kind of good points about why and when to modularize your application. Because then, at some point you want to modularize even more than just by layers. You also want to do it by features. Then you have Uncle Bob's talk about clean architecture, and I hope it will be understandable with this kind of more insight about what those layers are, and the original blog post, which also kind of makes more and more sense as you know more about clean architecture. And then thank you, and obviously if someone has any questions, then either, I don't know, now or basically I'm around.
You have a code example of interface adapter?
Code example of an interface adapter? No, I don't. So, no, I do not. I would say the most kind of typical interface adapter that you probably know about is a presenter, which will call the use cases, interactors, and it will expose some kind of some representation for the UI. Normally in MVP or MVVM, you will have this class that holds all the UI logic, but it doesn't know exactly how the UI is drawn. So you have this class or something that tells, show this button, hide this button, and gives you information about what was clicked. So the typical interface adapter would be a presenter. And that's kind of the closest thing.
You mentioned that the domain should be discovered and that it should be pretty much a reflection of the business.
Yep.
How to deal with introducing clean architecture into a system that already exists. Let's say you have a REST API that didn't follow that clean architecture approach. You want to make a clean architecture app on top of that.
Yeah, so the question was how to introduce clean architecture into a system that's not really clean. Like we have the domain, which is defined, for example, by API models. That's pretty difficult, and I don't really know. I was in this situation once, and it was the more difficult because even if you have this problem with the domain that the models aren't really the proper domain, then it means the rest of the app isn't either. So the best thing you can do is actually start working, take this whole code base, and whatever new feature you add, you write it side by side. And then gradually it will turn out that you need something from the domain, from the old domain. And at that point, what you want to do is you want to write it again, but properly, and then gradually migrate. But it's kind of, I don't know, impossible, probably not. I was in the project for 1.5 years, I think, and it didn't work out. We didn't manage to do it right. Yeah, that's a difficult. Unless you can just take a class and say, I will take this model, fix it, and all the instances of it, all the use cases, and you'll work through all the layers and fix it once, and then again, that might work, but it's not an easy question.
I have a question. For example, if your business is related to graphics or, I don't know, maybe like geographic things.
Yep.
So then you either need to implement your own point, rectangle, because otherwise you would need to use Android.
Yes, so you definitely don't want to use Android, right?
Yeah, so then you need somewhere bridge them together, yes?
Yes. So essentially, yes. And if you know that clean architecture might not work in every case, I believe it probably should, but I really don't have. I can't tell for sure that with graphics application it's the same. But if you want to reuse some logic with the other platforms and just talk about it in a clean way, then you should have some kind of your own definitions of point.
Yeah, I did it like that, but then I didn't feel very good about it because then I had a lot of classes that I had to bridge, and then I was thinking,
yes.
Why am I bridging it
Yes.
Android has it, but then you don't have unit test. You need to have Android test. And
This is very specific, because if you're already talking about the graphics in the domain, like if you want to say about pixels and stuff in the domain and you want to test it, that's.
But also it's the same if you have an app that works with like maps or GPS, then you also have coordinates. You can
coordinates.
Also,
Yes.
So it's also Android has them, or you also make your own classes. Yes.
You will probably have to duplicate some things, and it feels like duplication. But again, this is the part of the worth it in the long term. I can't really say about a case where I felt entire domain was duplicated from something, because I didn't.
No, but sometimes it's a huge part of domain is duplicated.
Might be. We can talk about this later, because maybe it's not the proper domain either.
No, I just wanted to hear, like, I had the same feeling that you should do it, so you are really clear. But
Okay. Any more questions? I think not. Okay, so thank you again.